some examples when it comes to similarity. Okay, so you should have the sheet of paper. If you don't have the sheet of paper, you can pause the video, copy it down, or pick up a copy from me. All right, so the question is, are these shapes similar? Yes or no? Remember, what does the word similar mean? All right, it means the same shape, same angles, and what can you tell me about the sides? Sides are, what are they? Proportional. So I'm looking for the same shape. They look the same shape. Same angles. Do they have the same angles? 2, 1, 2, 1, 2, 1, 2, 1. Yes. And the sides are proportional. So when it's asking me if they're similar, it has to make sure the same shape, same angles, okay, and the sides are proportional. So that's all I need to check. If the sides are proportional, then it is similar. So let's set it up. Now remember when I told you I'm going to stick to one thing the whole way. I'm always going to compare the figure to figure. Okay, so I'm going to look at this figure only, and I'm always going to start with the smallest number, so it goes 24 to 36. So 24 to 36. And remember, the order must be the same. So the order must be the same. I started from the smaller number, then I went to the larger number. Okay, so look in here. What number do I start first with? What do I put right here? 18. And here I put 27. And remember, if the sides are proportional, then these two shapes are similar. All right, so if these two are equal to each other, then they are proportional, and so that the figures are similar. All right, so a couple of ways you could do this. I'm not sure if they're going to give you a calculator. If they give you a calculator, just punch it in, and whatever it is, it is. So for example, 24 divided by 18 is 1.333 equals 36 divided by 27, which is also 1.333. Are those two equal? Yes, they are. So because they're equal, that means the sides are proportional. These two shapes are similar. So the answer is a yes. Now, if they don't give you a calculator, that's okay. All you have to do is reduce this to its lowest terms, and that will show you that they're equal to each other. For example, what number goes into 24 and 18? Let's do 2. 2 into 24, 12. 2 into 18, 9. Is there a number that goes in 12 and 9? Yep, 3. 3 into 12, 4. 3 into 9, 3. Is there a number that goes in 4 and 3? No, that's as low as you can be. So if I can make this look as 4 over 3, then they're similar. What goes into 36 and 27? Let's do 9. 9 4 times, and 9 into 27 3 times. So do you see how it's 4 over 3? It's exactly the same. And guess what? If you did 4 divided by 3, you still get the 1.333. So if they don't allow you to use a calculator, you know how to do it without a calculator. I will always allow you to use a calculator, so it could just be faster, but you know how to use it. No, either way. All right, so are these two shapes similar? Yes, they are, because the sides are proportional. It's the same shape and has the same angles. All right, so taking a look at number 2. Are these two shapes similar? All right, remember what we're checking for. We're checking for the same shape. So is it the same shape? Yeah, it looks like the same shape to me. All right, are the angles the same? So take a look at the angles. Are they the same? No, because look, it goes 1, 1, 2, 2, right? Look, this one has like 3, 3, 4, 4. So no, I can already tell that these are not similar. Okay, because it has to have the same shape, same angles, and the sides are proportional. So I don't even need to look if the sides are proportional to each other, because they don't have the same angles. So they are not similar. Okay, take a look at number 3. What is the measure of angle U? Now, I'm going to show you how to cheat, because I haven't shown you this the last time. I should have, but I wanted you to kind of make sure that you could look at the shapes and tell. Show you how to teach really quickly. This is always in order. Anytime you're doing similar or congruent, triangle TUV has to be in order. All right, so if angle T goes with angle D, angle U goes with angle F, angle V goes with angle E. So when it asks you what is the measure of angle U, find where U is. So that's right here in the middle, right? That means it's the same as where that is in the middle. So U is the same as F. Then just look at F, and that's the same thing as U. You don't even have to figure anything else out. So what's angle U? 59. All right, nice and easy. All right. If the two, this is, by the way, the symbol for similar. Okay, so this is the symbol for congruent. This is the symbol for similar. All right, so number 4, the two triangles are similar. Find GH. So I'm going to find GH, and I'm going to put an X there because that's what I need to find. All right, now, just to be safe, don't use your eyes if they ever give you the two triangles are congruent. Use this because just like I said in this one before, they each correspond to each one. So GH, okay, GH, so from G to H is the same as going from R to Q. So find R to Q. So this goes with this, okay? Then find what GF goes with because that's the other one that we know. GF, so it's going backwards like this. GF, so it's going to go RS. RS. So we're going to need this one. So we do not need that. Okay. Now remember I told you I was going to compare for me in one way. All right. So I'm going to start with GF. Okay. GF or FG. FG goes with SR. So I'm going to say 6 goes with 12. And if I started from this shape, I have to start from this shape again. So X goes with what? HG or GH. GH goes with RQ or QS. RQ. I mean, sorry, RQ or QR. RQ. So 16. All right, once you have your proportion set up, go ahead and cross multiply. So we're going to do 16 times 6 is 96. Equals 12x. All right, then we're going to divide by 12. So we're going to get x is equal to 8. All right, is this the only proportion you could have set up? No, not at all. You could set it up however you want to as long as the order is the same and you start from the same place each time. So x is equal to 8. All right, let's take a look at number 5. Question is, are these two triangles similar? If no, type no in the clicker. If yes, write the similarity statement. Okay, so if it's no, you're just going to say no in the clicker. If it's yes, you're going to say PQR is similar to, and remember you have to follow the same order if it's yes. All right, so let's take a look. It looks like they give us two angles, and remember, all right, from our notes, and in fact this is a very good example. If two angles are the same in both triangles in the same place, then they are similar. So this is similar by the AA theorem, postulate, I'm sorry, by the AA postulate, because the two angles are exactly the same. All right, so you see it goes 110 and 30, 110 and 30. So yes, they are similar, but in the clicker we're not saying yes, we're writing down the statement. PQR, and this is how I want you to show me work. You go from P to Q to R. So you have to go in that same order on this triangle. So I went from 30 to 110 to nothing. So I go from 30 to 110 to nothing. And now you have your order, D, E, F. And this is how you show me work. Okay, this shows me that you know exactly what you're doing, D, E, F. All right, because of AA. All right, so remember, if you have AA, SAS, or SSS, then they are similar if the sides are proportional or if these two angles are congruent. All right, perfect. Let's take a look at number 6. Are these two shapes similar? So again, they give us two angles, it looks like. Are they the same? If they're the same, it's similar again by AA. Yes, it is, because one is 61 and one has one arc. So they both have one arc. So yes, it is. Now you have to find the order. IGH. So it goes IGH. IGH. All right, now you have to go the same order on this one. It goes 1 to 61 to nothing. 1 to 61 to nothing. So it goes like that, and then just read it. It goes RQP. RQP. Okay, and then that's what you'd put in the clicker, RQP. All right, number 7. Are these triangles similar? Okay, so again, you're looking at it. What do they give you? They give you 3 sides. So again, if we can prove side, 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 which means all the sides are proportional, then we know that they are similar. Okay, if not, then it's no. Now remember, I said I'm only going to do it one way, but again, as long as the order is the same, you're fine. I'm going to always look at one shape, start from the smallest number, second largest, largest. So I'm going to go smallest, which is 12, equals next smallest, which is 14, equals the largest, which is 19. So I go small, middle, large. So on the next shape, okay, on this next one, I have to do the same. Small, middle, large. So small is going to be 12, middle is 14, large is 21. And if all these are equal, it is similar. Because remember, if your proportions are equal, then it is similar. Well, 12 divided by 12 is going to give you 1. 14 divided by 14 is going to give you 1. So far, so good. 19 divided by 21, I don't know what that is, but it's not 1. 19 divided by 21 is 0.904. So this is 1.904. All those numbers equal? No. So are these two triangles similar? No. Okay, because you cannot prove that the sides are proportional. All right, so 1 is equal to 1, which is not equal to 0.905, just to round. Okay, so these are not proportional. I will type no in the clicker. Number 8, are these triangles similar? All right, so again, looks like they give us all sides. So if we prove by SSS that all the sides are proportional, then these are proportional. So again, look at the first one. All right, smallest to largest. What numbers are equal? So I go 80 equals 128 equals 144. So small, middle, large. So then I do the same thing on this one. Smallest number is going to be 110. Middle number is going to be 176. Largest number is 198. All right. If they're all equal, it's proportional. So take my calculator. 80 divided by 110 is 0.72. Okay, so 0.727 equals. Do the same thing here. 128 divided by 176, 0.727. Okay, equals. And if this last one works, then it is proportional. Divided by 198. Yep, 0.727. All right, so they're all equal. So yes, it is similar. These are similar figures. In other words, the sides are proportional. Write the similarity statement. Okay, so it starts QRS. So he goes QRS. So look at how those numbers go so that you can set this one up the same way. So it goes from the largest to the smallest to the middle. Isn't that right? Largest, smallest, middle. So find the largest to the smallest is going to be here and then the middle. So that means we did this. All right, then read that. VUW. And again, this is showing me all the work. So in your test, I want to see this exact same thing. All right, so that's number 8. Take a look at number 9. All right, if it tells you that two triangles are similar, find TU. Okay, so that two triangles are already similar, find TU. So first, let's find out TU. TU is right there. Put an X. All right. So remember, I'm going to go with, anytime they give me this, I'm going to go with what they have. So TU is the same as CD. Okay, so I'm just going to set it up like that. So X is the same as CD. Where's CD? CD, 18. Now, I started on this triangle on the right, so I have to start from this triangle on the right again. The only number they give me on this one is 3, and that's SU. So from S to U is going backwards that way. That's going to be ED. ED. Okay. Go ahead and cross multiply. Or, well, let me just stay consistent. You could probably do this a little bit faster. If you did 18 divided by 18, then times 3. But I don't want to confuse you. I'm going to stay consistent. 18x equals 18 times 3. 54. Divide both sides by 18. X is equal to 3. Okay, so TU is equal to 3. All right. Number 10, in the diagram below, they're telling you this. These two are similar, find U. So here's U. All right, so you just need to know what goes with that. So U is PN. PN, so I need MN. So U goes with MN, which is 3, over Okay, I started from this triangle, so I have to start from that triangle. The only other number on that triangle is 10, and that's ON. So ON, it jumps one, right? So it's going to be LN, which is 5. Okay, go ahead and cross multiply. 5u is equal to 10 times 3 is 30. Divide both sides by 5. U is equal to 6. Okay, so u is equal to 6. All right, number 11. Same thing. Anytime you have triangles that are together, remember my rule. I like to separate them, okay? Because it just gets a little bit confusing. So I'm going to draw this small triangle here. And I'm going to draw the big triangle. All right. And I'm going to label them. So looking at just the small triangle, I have P and I have 4. Okay. Looking at the large triangle, this one right here is 6. And from here to here, because it's the whole thing, right? From here to here, it's not just 4, it says it's 8. Now, once I have my two triangles, really easy to see. P goes with what? P goes with 6. If I start from this triangle, I have to start from that triangle again. So 4 goes with 8. Cross multiply. 8 times P is equal to 4 times 6. All right, divide both sides by 8. You're going to get P is equal to 6, 3. P is equal to 3. And that's it. All right, take a look at number 12. Which rule explains why these triangles are similar? All right, so it's asking you for the rule. That means it's asking you for AA, SAS, or SSS. All right, so do they give you 2 angles? No. Do they give you 3 sides? No. It's SAS. Okay. I'm going to always start from the smallest to the largest. So smallest angle, largest. Okay, that's how I'd read it. So smallest angle, largest. Now, don't assume that it's automatically SAS, because remember, these sides have to be proportional. So first I got to prove that they're proportional. If they're proportional, it's SAS. If they're not, it's none of the above. So 11 goes, I'll do smallest to largest looking at the first triangle. 11 to 14 is the same as, so small to large. So looking at this one, small to large, 10 to 15. If these are equal, then it is by SAS. If they're not, then it's not. 11 divided by 10 is 1.1. 14 divided by 15. 0.933. Are these two numbers equal? No. So it's not SAS. It is none of the above. Because for it to be SAS, the angle has to be the same, which you can see it's the same. It's 82, right? But the sides have to be proportional, and the sides are not proportional. Remember, if the sides are proportional, once you set up the proportion, it'll be equal to each other. So it's actually none of the above. Right, number 13, which rule explains if these are similar. It looks like they have 3 sides, so it would be SSS. So let's check if it's SSS. If the sides are proportional, then it's SSS. So I'm going to start, this one goes small, middle, large. So 90 equals 135 equals 153. I went small, middle, large, so I have to go small, middle, large, another one. So small, 80, middle, 120, large, 136. If all this is equal, then they are proportional by SSS. If it's not, if even one is off, it's none. All right, so 90 divided by 80, 90 divided by 80 is 1.125. 135 divided by 120. Oh, it looks looking good, but you have to check all 3. 153 divided by 136. Yup, it is. So 1.25. Because they're all equal, it tells you the sides are proportional. Because the sides are proportional, what rule explains it? It's going to be SSS. Because if all the sides are proportional, then the triangles are similar. All right, 14, last one. Are these triangles similar? If yes, if no, type no in the clicker. If yes, write the statement. Again, so this looks like SAS, right? SAS 12 too big to 18, so 11 to 20. All right. Angles are the same. Check. All right. So now I have to just prove the sides are proportional. So I'm going to start with this one triangle, 12 to 18, small to large. So 12 to 18 is the same as small to large, 11 to 20. If those are equal, then it's SAS, or it's similar, actually. And so you just write it down. So 12 divided by 11, 1.0909 equals 18 divided by 20 is 0.9. Are these equal to each other? No. So are these triangles similar? No. All right. And that's it. That's all there is to it. So if you can do this sheet of paper, you're going to be fine on your IXL. You're going to be fine on your IXL test. Let me know if there are any questions.